Good morning, guys. It's Miss Young. I hope you all have had a good week so far and things are going well for you in math. Today we're going to be looking at the different components of what you might encounter in a SNAP. Remember the SNAPs from last year? Mrs. Lesson might have given you a number sense SNAP where you had to write the number and model it and explain your model. That was something that I had posted last week, I believe, a video on how to complete that SNAP correctly. But for this week, today we're going to go over a SNAP that is an operation SNAP. So we're going to pretend that we have a problem. Well, let's see if my pen will work for me here. Okay. Try this. We're going to do 32 times 12. So there is our problem. Now, we are going to start off with modeling it. Well, in order to model multiplication, last year you guys spent a lot of time doing area models. So in order to draw an area model, I'm going to need to draw a rectangle. And then I'm going to need to decompose the numbers. So 32, if I think of, well, how could I decompose 32? I think of 30 plus 2. Now I'm going to look at my other number. How could I decompose 12? Well, 10 plus 2. Now last year you might have completed area models that only had 2 sections to it. For us, this year, as 5th graders, we're going to expand on that a little bit. And so our area model is going to actually have 4 sections. So we're going to start off trying to find the area of this section. And if I look, this section has a length of 30 and a width of 10. So in order to find the area, I'm going to multiply 30 times 10. If I count by 30 10 times, I should get 300. Excuse me. Now I'm going to try to find the area of this section. This section has a length of 2 and a width of 10. 2 by 10, or 2 times 10, is going to give me an area of 20 units. Now I'm going to look at these other 2 sections. This bottom section, the longer rectangle, has a length of 30 and a width of 2. I could think about that as 30 times 2, or 30 by 2. And 30 by 2, or 30 times 2, is going to give me an area of 60. The last section, the small section, is this part right here. This section has a length of 2 and a width of 2. So we're looking at a section that's got a length of 2 units by a width of 2 units. And 2 times 2 would give me 4. Now I found all of the areas of these partial rectangles, but I want to know the area for this entire rectangle. I'm outlining it here for you so you know what I'm talking about. So how am I going to do that? Well, I'm going to add all these partial areas. 300 plus 20 plus 60 plus 4. Add them all up. 0 plus 0 plus 0 plus 4 units, or 4 ones, is going to give me 4 ones. If I have 2 tens and 6 tens and I add them together, I'm going to get 8 tens. And then if I have 3 hundreds and no other hundreds, I get 384. So that means there are 384 units that it would take to create this area model. Now, one of the other parts of the area model on the SNAP is thinking about, when could I use this in real life? When would I have something, 32 of something, and repeat it 12 times? So I'm thinking about, what if I had, maybe it's Christmas time. Christmas, I love Christmas. What if it's Christmas time and I buy 32 presents? Each present costs $12. What's going to be my total for my presents? $384. What if I think about school? What if I had 32 classrooms and each classroom had 12 students in it? How many students would be in the school? 384. What if I was buying water for a concession stand? Maybe there's a baseball game going on and we want to make sure here at the school that we have enough water for the people that come to watch. So in this case, what would make sense? Well, it would make sense to say that I bought 32 cases of water and each case had 12 bottles in it. So how many bottles of water would I have? 384 bottles of water. When we complete that SNAP, we want to think about, when would I ever see multiplication like this in real life? And in this case, I was able to think about it in a concession stand. I was able to think about it with schools and classrooms. And I was able to think about it at Christmas time, that I bought 32 presents and each present cost $12. So push yourself to think about that. One of the last things that the SNAP asks is for a reflection. When you reflect, like the video last week, I reminded you that the reflection is kind of the moment where you really grow a lot as a mathematician, because you want to think of a couple things. First of all, when you're reflecting, or when I'm reflecting, I like to think, well, was anything difficult for me? One thing that may have been difficult for you, if you were doing this on your own, is adding this other digit. Maybe last year in 4th grade, you had digits like 32, but maybe you were multiplying them by a 1-digit number instead of a 2. So maybe adding that second digit down there, maybe that was difficult. Maybe thinking about a real-world example is difficult. Maybe your mind just kind of goes blank and you can't think about a time where you would actually multiply 32 by 12 in real life. On the other hand, maybe this would be really easy for you. If it is really easy, then you can think about, okay, well, did I make any mistakes today when I was solving this? Maybe you made a small multiplication error and you caught that. You might say, you know what, Miss Young, this was really easy for me, but you know what, I made a small multiplication error that I had to go back and fix. I accidentally said that 30 times 10 is 30, not 300. I forgot that extra 0 in the ones place. And maybe you say, oh, Miss Young, I caught myself. I realized that doesn't make sense because I'm taking 30 and adding it to itself 10 times. So it can't be 30 times 10 is 30. 30 times 10 is 300. It's growth like that that's really going to help you develop into a really strong mathematician. Hopefully this video was helpful. I hope that you guys have a great Labor Day weekend. Continue to be safe and practice that safe social distancing. Bye-bye.